Hi everyone, thank you for joining. Today I'll be presenting a quick overview of entity relationship diagrams, also known as ER diagrams, and how we can use them to model real-world data using a practical example from a physician's office. So what is an ER diagram? An ER diagram is a visual tool used in database design. It is created during the initial design phase of database, and it helps translate real-world processes into database structure. Why do ER diagrams matter? They are important because they help us fully understand how the data in a system connects before any code is written. They reduce confusion, minimize errors, and improve communication between developers and stakeholders. Think of them as a blueprint for building a database that actually meets user needs. There are a few main components of ER diagrams. The first three are the most important and the rest follow. The entity is the main object, such as patient or doctor. An attribute is a characteristic of that entity, which could be name or email. And then there are relationships, which is how entities interact, such as patient receives reminder. On the right hand side, you will see shapes, and each of those shapes are meant for those specific components. So entities belong in rectangles, the ovals hold the attributes, and the diamonds hold the relationships. The remainder of the terms are entity sets, which is a group of similar entities. There's the domain, which is valid values for an attribute. Keys are uniquely identified as an entity, and the primary key is the chosen key from candidates to uniquely identify each record. There are different types of relationships, which are one-to-one, one-to-many, and many-to-many. One-to-one is when one entity relates to only one other, such as one student has one ID card. Next is one-to-many. One entity connects to many others, but not vice versa, such as one doctor treats many patients. Then there is many-to-many. Many entities on both sides are related, such as students enroll in many courses, and courses have many students. Lastly, we have descriptive attributes, which are details about a relationship, not entities. So what does an ER diagram look like? So we have an array of rectangles and diamonds and circles, and just like stated before, the attributes are the circles, the entities are the boxes, and the diamond would be a relationship. And so I would like to use a scenario just to kind of put it into practice. A physician office wants to send reminders using emails to their patients. To do this, they would like to use a database to keep track of which reminders are sent to which patients. A reminder has a reminder ID, a subject, and a body. A patient is identified by email address, and patient's data includes a name and address. When a reminder is sent, the data is recorded. And so this is a breakdown of that scenario into entities and relationships. So the entities would be patient, reminder, sent reminder. The primary key for patient is email. Its attributes are name and address. For the entity reminder, primary key is RID. Attributes are subject and body. Lastly, sent reminder is a relationship entity between patient and reminder. Attributes is sent date. And this is the final diagram of that scenario that we just ran through. final thoughts. To wrap up, ER diagrams are a powerful tool for designing efficient, meaningful databases. They help us clarify relationships before development begins, and they make sure that the system we build actually supports the needs of the organization. This reminder tracking system is just one simple but very helpful real-world example of how ER modeling can help. I did include references that I used. These two sites are extremely helpful in learning even more about ER diagrams.